So here we are. This is the last video in the series. This is part 11 of negative sequence made easier. And in this one, I want to go over how do we assess the testing, right? What's a passing test? And, at the end of the day, you got to read the manual, right? So we were reading the manuals for reasons. We were going ahead and we were finding how to calculate every single one of these, and that tells us where it should pick up, right? We also did the timing for several of these because some of them have actual, curve-based time delays. Now, um, once you have those values, how do you determine whether or not it's passing or failing from that value? And some of these older ones, it's going to be a little more challenging. So you just have to kind of go with what you have, and you don't have a lot. Okay, so this we'll start right here with the Westinghouse Data IQ Plus. What you find inside of there is that they have an accuracy of the reading, which is plus or minus 1%, and that's all they really give you. So there's nothing else on this one. You're just going to have to go with that, and then also you can lean on NETA with timing. So whether or not it's instantaneous or not, I would honestly go with a plus or minus 5%. And if it's greater than 1 second, if it's less than 1 second, obviously it'd be 50 milliseconds. That's you don't want to go any faster than that. Okay. But just this is all you're going to get out of this manual. So you kind of have to do the best you can. Okay. The Basler, it has inside there, it tells you what the pickup accuracy is. It's right here. And it tells you your timing is going to be right here. Okay. And this also, back in the day, this is where a lot of this stuff came from. Plus or minus 5% or 50 milliseconds, whichever is greater. Okay. So, and then the inverse time is also along the same lines. Okay. So the Basler, they give you that information, which is great. Now let's talk about the Westinghouse IQ 1000. And again, this is another older relay, and they don't give you much. Okay, so what I did was I went to the newer relays, which these are the successors that are replacing everything, and they give you a phase current accuracy right here. So this is like a metering accuracy, and then they give you a timing accuracy right here. You don't really have a pickup accuracy, so the only thing that you could do for the pickup accuracy is assume that it's based off the metering accuracy. Okay, which may or may not be true. Play that one by ear. You don't have a lot of assessment material for this, so you might have to lean on a NETA book instead, okay? Like I said, use the NETA specs for as much as you can, and the rule of thumb usually is plus or minus 5%, and when you're below 1, then you're just going to use 50 milliseconds or 0.05 or 50 milliamps, whatever you have. Now let's talk about the GE369. As you get into some of these newer relays, what you find out is that they do give you metering accuracies. They do give you output contact times. Okay, so this is how fast this should all be. But you don't really need any of that because most of the time they come here and they give you this, which is great. So your pickup accuracy for the element itself is 2%, and the timing accuracy is this. So then what's this up here? Well, this is when you do the metering check, and it tells you on the front of the relay that it's 49.2 amps. It should be 0.5%, okay, plus or minus 0.5% of 2 times the CT. So if you have 5 amp CTs, right, that's 10, and then it's 10. So it's 0.5% of 10 amps. Okay, and that's plus or minus your value. So hopefully you're reading these properly and following this. It's not just 0.5%. Don't think that. It's of 2 times CT. So make sure you follow it appropriately. The GE469, again, they go ahead and they give you a lot of the same thing. This is metering accuracies, operate times, but you don't really need that because, again, they give you the protection timing right here. And like I said, these protection timings, gosh, that is a lot of time. 0.5 second or plus or minus 5% of the total time, usually whichever is greater. And then it even tells you down here, note 1, it can be even longer, another 16.7 milliseconds if you have a certain setting enabled. So yes, there is slop in these, and just be careful. And then they don't have shown here. Oh, they do. It's right here. Pickup accuracy is 2%. So sorry, I didn't see that. All right, the 869. Again, they're going to tell you metering accuracies, your output relays, all of that stuff's here. That's great. But also they give you the current unbalance. Okay, so this is it. This is what you need. And really, most of these, that when they give you a metering accuracy for CTs, and also a output relay, and then they also give you the protection. You shouldn't really have to lean on these specifically. Okay, you really should just use this protection as everything that you need. Okay. The SEL 710. This guy, that again, the SEL is similar. Reading the manuals is similar to the GE manuals, and so they have the current unbalance listed right here. It's plus or minus 2% of the reading, plus or minus 1.5% of I nominal. So if I nominal is 5 amps, it's a nominal 5 amp CT circuit, right? Then 1.5% of that is plus the 2% of the reading. So if you're reading FL around FLA and it's 3.2 amps, right, you're going to be times 0.02, right? That's 2% of that reading plus 1.5% of the 5 amps. So this is going to be 5 times 0.015, which is 1.5%. You're going to add these up, and then that's the total current unbalance. Okay, so just make sure that you're following this right, and you should be good with that. Again, current unbalance to accuracy. Look at this. This over here was metering inaccuracies. But then when you get to this is the actual protection inaccuracy, and it's 10% of the setting, which is wild, right? So that, I mean, if the setting is 3 amps, then it's plus or minus 0.3 amps. That's a lot. And the accuracy for the time delay is 0.5% plus or minus a quarter cycle. So this one's actually fairly quick. Okay, not as sloppy. If you've gotten to the end of this, that's great. The goal in all of this is to know how to test before you run the test. If you are one of those people who goes ahead and runs it first, figures out how it times, and then rebuilds your test module and says it passes because you know what it timed at, you're not testing anything, okay? You should know what it should test at for pickup and for time delay before you ever start the test. You should be able to calculate everything. And if you don't, then you're in over your head and you need to start reading the manuals and figuring stuff out. So hopefully this helps someone. And if you got into the end and watched all of these videos, kudos to you. They're not easy, and I hope you have a great day. Thank you.